Okay, so the topics that we're going to talk about today are tree diagrams and sample space. So we have combined these two things because if we draw a tree diagram, it really can help us to write our sample space. A tree diagram is really just a way to represent what's happening in a probability experiment, and you'll see that here in just a second. A sample space, again, we can write that from our tree diagram, but a sample space is a list. So we're going to list it out, a list of all possible outcomes in a probability experiment, okay? So we're going to write a tree diagram, and then we're going to list all of the possible outcomes to make our sample space. So the first tree diagram that we're going to work with, let's say we're going to flip this coin down here at the bottom. So we have just a regular old coin. So I always start my tree diagram from a point, and then there are two different outcomes. So that means I'm going to have two different branches, and one outcome is the coin landing on heads, and one outcome is the coin landing on tails, okay? So that is probably the most simple tree diagram you're ever going to see. There are your two outcomes. So let's say from this tree diagram, I can use this information and I can now make a sample space. So as I write a sample space, we always put it in brackets, okay? And the things that can happen, one of the outcomes, the coin can land on heads. The other outcome, the coin can land on tails. And then we bracket it at the end. That is probably the most simple sample space entry diagram that we will see. You'll probably also see some people just put H and T, okay, for landing on heads, landing on tails. So that one's a really simple one to start with, okay? So you took all of the outcomes that probably would happen, and then we took and we wrote our sample space over here on the right. So let's try another one, maybe one that's a little bit more difficult, okay? So if we have this spinner down here at the bottom, we have 1, 2, 3, 4, 5, 6 different things, okay, that could happen. So if we just wanted to spin this spinner one time, we're going to start our tree diagram here, and there are 6 outcomes. So 1, 2, 3, 4, 5, 6. So we're going to go to our spinner, and we're going to actually write down the things that are happening. So one of them is blue, and I'm just going to work my way around the spinner. That way I know I have all of them. Then it would be red. Then you could actually land on yellow. Okay, then green. Then red. Then blue. Okay, so if we were to make a tree diagram with just one event, notice it only has one line right here. This whole thing is one event happening. That's our first spin. Okay, it doesn't have anything branching, off of this side or off of this side because we're not doing another event yet. So just a one event, it looks like we have 1, 2, 3, 4, 5, 6. You should be able to read your tree diagram and see how many events you have and how many outcomes you have. So let's put it over here with our sample space. Let's write it as a sample space. So we'll put it in our brackets, and I'm going to work my way from the top all the way down to the bottom. So the first would be blue. I'm just going to write B for blue. Next would be R for red. Next would be Y for yellow. Next would be G for green. Then R for red again. And then B for blue. Okay? Notice that I did write R twice and B twice. That's because they are both represented twice on the spinner. So both of them are outcomes. So we're going to write both of them in our sample space so that we can see what is happening, okay? So let's say that we're going to do a compound event because that's where it gets a little more intricate with these tree diagrams. Let's say that we are going to spin the spinner and flip the coin, okay? Spin the spinner and flip the coin. Let's say that we spin the spinner, and we're going to kind of go back to what we did before. So we'll have to start our tree diagram just like we did before. So there's 6 outcomes that could possibly happen. 1, 2, 3, 4, 5, 6. So we'll go around the spinner again. So we'll have blue, then we'll have red, then yellow, then blue, then red, then green, okay? That's our first event. That's the first thing that can happen. Is the first thing that's going on is we're spinning the spinner. The second thing that's going on is going to be our second part of this tree diagram. So after I spin the spinner, then I'm going to flip the coin. So let's say it lands on blue. The next two options, it could land on heads or tails. It could be red and land on heads or tails. It could be yellow and land on heads or tails. It could be blue, heads or tails, red, heads or tails, and finally green, heads or tails. So as we're talking about how many possible outcomes are in this experiment, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 possible outcomes, okay? So let's write it like this. We're going to kind of follow the tree diagram, and we'll write like this. So it could be blue and land on heads, blue and land on tails, red and land on heads, red and land on tails. We're just working our way through our tree diagram. Yellow, land on heads. Yellow, land on tails. Blue, land on heads. Blue, land on tails. Red, land on heads. Red, land on tails. Green, land on heads. And green, land on tails. So that would be the end of my sample space. So notice I did write out all 12 things. We said there were 12 outcomes when we looked at our tree diagram. And I wrote out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 things. Okay? So as you're looking at your tree diagrams, make sure your outcomes that you list in your sample space, which is right over here, those outcomes should match the number that are on your tree diagram as well. So every time you do a tree diagram, your sample space should really match that.